Hi all, hope you're having a great day. Thank you so much for turning in the basic logs and expos graphing. Today what we're going to do, and tomorrow we're going to talk about graphing when it comes to transformations. So just like we did with quadratics and rationals and radicals and absolute values, we're going to do the same thing here. Today we're just going to focus mostly on exponentials with intro to logs, and then tomorrow we'll do mostly logarithms, okay? So how can you transform the graphs of an exponential and log function? That's kind of what we're focusing on the next 2 days. So first thing I'd like you guys to do before we do anything is I want you to look at these equations here, right here, and I want you to say, okay, let's match these up with the graphs and then we can investigate some information. First, I just want you to kind of see if you can figure things out by looking, see what makes sense. Just to recall, sometimes we kind of forget, when we have an exponential function has a horizontal asymptote, okay? So a horizontal asymptote on the parent function is at y equals 0, but that can change, okay? An exponential function also crosses at 1 comma b, and it also always crosses at 0 comma 1. We learned about that in the last set of notes. So those are things we know from the exponentials. We haven't done much with logarithms yet, but exponentials and logarithms are inverses of each other, okay? So we're kind of to sum that up. With exponentials, we have this information. So with logs, and remember natural log is the same thing as log base e. So with logs, we're going to have a vertical asymptote at x equals 0. It's also going to cross, instead of being at 0, 1, 1 comma 0, okay? And then it would be b comma 1, and those have to do with the parent function again. This is at our parent function, just like this is at our parent function, okay? And just like this is at our parent function. Those can change just kind of depending on what the equation's trying to do from there. So let's go back and look at our graphs in a little bit and see if we can use this information that we've been talking about or kind of investigated to solve these. So right away, I know, and if I look at the picture a little closer, I know that number 3 has a horizontal asymptote. I know number 6 has a horizontal asymptote, okay? And I also know that number 1 has a horizontal asymptote. So those must then be exponentials because horizontal asymptotes go with exponentials. I then look at the graphs and say, okay, which one has vertical? Well, 2 has a vertical asymptote, and I can kind of tell that my vertical asymptote is right down there on where x equals 0. 4 has a vertical asymptote, okay? And 5, you can kind of see in the picture as a vertical asymptote. So those are my vertical asymptotes. My horizontal asymptotes are here where this red line is, and here where this red line is. So that kind of helps us that 2, 4, and 5 are going to be logarithms because they have a vertical asymptote. And 6, 3, and 1 are going to be exponentials because they have horizontal asymptotes. Okay, so right away that helps. So let's just look at exponentials to start because all we're kind of focusing on today is exponentials. So let's look at those first 3 equations. Well, let's go back to quadratics real quick and say, okay, vertex form. Okay, that was y equals a parentheses x minus h squared plus k. Can we somehow change that to exponential? Absolutely. So an exponential equation would be y equals a, okay, rb to the x minus h and then plus k. That would be our vertex form, in quotes, of exponentials, okay? The same would hold true for logarithms, just so we can kind of get that out of the way as well. An exponential would be that. A logarithm would look like this. Y equals a log base b of x minus h plus k. Okay, so those would be our vertex form. Just like in radicals and rationals and quadratics, a, h, and k do the exact same thing all the way through. That's why it's universally used, because there's no math kind of needed there. It just kind of learn it once and it's consistent. So let's look at these exponentials. Let's look at letter A. So A, I see that -3 is going to cause the graph to shift down 3, okay? which means that this original horizontal asymptote at y equals 0 would actually go down to y equals -3. So right away then, I know A has to go with 6. Okay? It also tells me that +2 tells me that the graph is shifting left 2. So instead of being at the 1b, it's going to shift left 2. Okay? So let's look at B. So B, that graph is, that -a tells it's going to reflect somewhere. Okay? And then that +1 says that our horizontal asymptote is actually going to go from 0. It's now going to go up 1. So if I look at 1, 3, and 6, those are my options. Well, the graph is reflected, so it has to be 3. Okay? And then our last one, C, because again, we're only exponentials today. I see that our K is -1, which means my horizontal asymptote has to be shifted down 1. And then my graph's going to be shifted left 2. So instead of being at 1b, it's going to be at 2, 0. Okay? So that's going to be shifting it left 2. So I know that C goes with 1. Okay? So those are exponentials. Again, we'll talk about logs more tomorrow. So let's look a little bit at the next slide. Let's bring all those together. So when I look at this problem here, here are my transformation rules. Okay? So with logs, just like we talked about before, when I'm looking at them, I know that H moves the graph left and right, okay? And H is always the opposite of what you see. I know that K causes the graph to go up and down. K is exactly what you see. A negative base tells it flips over the Y, okay? A negative in the exponent tells me actually it flips over the Y. A negative outside tells me it flips over the X. And then horizontal and vertical stretch, we're not going to talk too much about those. All you need to remember is the rules. That if A is a number greater than 1, it's going to stretch. Okay? If A is a number between 0 and 1, it's going to shrink it. So when we talk about that type of stuff there, okay, when we look at this, we're not going to focus too much on what type of strength or stretch it is. We're just going to go really with the translations of horizontal and vertical, and then of course the reflections. So let's look at a couple examples to see how we're doing here. So I have this, it says, describe the transformation. So it's saying 1/2 x, and we graph it. We can just do a t-chart to graph it, graph a few points on it. We know that the parent function right here is going to have a horizontal asymptote at y equals 0, okay? And then it's saying take that graph there, which is in blue, and move it down 4. So then our horizontal asymptote moves to -4. Again, I would just do a t-chart to both and sketch the graphs, and I'd have both. So what is the graph doing? It's shifting down 4. Okay, that's what K causes the graph to do. We're also going to have you do the domain and range on these problems. So what does that look like when we talk about domain and range? So let's look at the first function, y f of x equals 1/2 x, okay? So our domain of that function there, we're just going to change it to y equals 1/2 to the x. Our domain is going to be all reals, so -infinity to +infinity. It's always going to be all reals for exponentials, okay? And our range, so let's think about that. If I start way down here, okay, and I'm going up, my graph does not exist until 0, because we're talking about the parent function here. So it would be 0 to +infinity, okay? It can't include 0 because 0 is where my horizontal asymptote is. So let's talk about the next one. So if I have y equals 1/2 to the x minus 4. So again, my domain and my range are going to be, domain is going to be -infinity to +infinity. My range, though, is going to change because my graph now starts right there at -4. It doesn't include it, but it starts at -4, and my graph goes off to +infinity. So on all these works, make sure that you are also identifying your domain and range and getting a good habit of doing it. It'll make your life a lot easier, okay? And then let's do one more example to make sure we're good. And then I would like you guys to practice on here and bring questions to me on them on the last slide that we talk about. So again, if I'm looking at the next one right here, I'm looking at this slide. It says describe the transformation with e to the x when the new function would be e to the x plus 3 plus 2. Well, we know that that plus 2 is going to cause the graph, the horizontal asymptote, to shift up 2. So our graph is going to go up 2. And then we also know that that positive 3, it's h. H causes the graph to go left and right. So that graph is going to go left 3 because h is always the opposite of what I see. So describing that transformation, up 2, left 3, that would describe it just fine, and that's the answer we would take. Again, the domain for both would be negative infinity to positive infinity. The range for the parent function would be from 0 to positive, and the range for the new function would be from 2 to positive infinity. Okay? If you need extra practice with anything, I would suggest just kind of working through these problems here and see if you can get the right answer when you're looking through it. Can you cause the graph shift left, right, up, down, and then the reflections? And then when you come to Zoom tomorrow, let's see if you've done any of these problems here.